This is a video for AQA Further Pure Mathematics, Calculus section 7.3, which is considering some further examples using reduction formulae. Well, I'd like to consider this example, which asks us first to find a reduction formula for In, which is the integral from 0 to pi by 2 of sine nx dx for n greater than or equal to 2. And then, having got that reduction formula, to evaluate sine to the power 5x and sine to the power 6x between those limits. Well, there are different ways of doing the first part, but one way is to first of all split the integral into the following: 0 to pi by 2 of sine x multiplied by sine to the power n minus 1 of x dx. And then we can use integration by parts. One part will be equal to sine n minus 1 x, which then differentiates to give u dashed equal to n minus 1 multiplied by sine n minus 2 x, and then the derivative of sine x, which is cos x. So using chain rule there. The other part, v dashed, is sine x, and so when we integrate that to get v, we get negative cos x. Integration by parts says that the integral is uv minus the integral of v u dash dx. So substituting those into the integration by parts formula, In will be uv, so that is minus cosine x and then sine the power n minus 1 x evaluated between 0 and pi by 2, and then plus, this is minus of a negative, so plus the integral from 0 to pi by 2 of n minus 1, and then we've got sine the power n minus 2x and cos x multiplied by cos x, so cos squared x dx. The first part of this we can evaluate, but when x is equal to 0, sine x is equal to 0, and when x is equal to pi by 2, cos x is pi by 2. So this evaluates to 0, and we're left with 0 plus this integral here still to evaluate. And that I'll consider on the next slide. So here we are looking at the integral where we've got cos squared here. We could use the identity that cos squared is 1 minus sine squared. And we can see then that we get this is the integral of sine n minus 2 x minus the integral of sine power n x dx. And that is to be evaluated between 0 and pi by 2. But these are basically the same as the original integral, so we can say that In is n minus 1 multiplied by, this here is In minus 2, and this one is In itself. And if we rearrange that, we get that In is equal to n minus 1 of In minus 2 minus n minus 1 of In. So in total we get that n is equal to n minus 1 of In minus 2. So let's just take a moment to recap that procedure then. We started off wanting to find the integral of sine nx and decided we could do it by splitting it into sine x and sine n minus 1x dx and using integration by parts. That produced the two paths, one of which evaluated to 0 and the other which we could then use an identity for cos squared x. The identity put in there is 1 minus sine squared and produce an integral which was essentially the same as the original integral. So this part of it is I n minus 2 and this one is I n. Rearranging that gives the final reduction formula. I n is equal to n minus 1 over n I n minus 2. The second part of the question asks us to use this reduction formula to evaluate some particular integrals. The first one is sine to the power 5x dx. So this is I5. So we can use our reduction formula to see that I5 must be equal to 4 over 5 I3. But I3, of course, is equal to 2 over 3 I1. But I1 is simply the integral of sine x, so sine to the power 1x dx, evaluated between 0 and pi by 2. The integral of sine is negative cos, so this is negative cos x, evaluated between 0 and pi by 2. So we get cos pi by 2, which is 0, and then minus of negative cos 0. So that gives us then 0 minus of negative 1, which is equal to 1. So we can see therefore that our final answer is that the integral that we've been asked to find from 0 to pi by 2 of sine to the power 5x dx, which is I5, is just 4 over 5 multiplied by 2 over 3. In other words, it's equal to 8 over 15. In the second part of the example, we're asked to use the same reduction formula, In equals n minus 1 over n, In minus 2, but this time to evaluate the integral of sine to the power 6 x from 0 to pi by 2. So we can see here that the reduction formula has given us I6 is equal to this product here, 5 over 6 multiplied by 3 over 4 multiplied by 1 over 2, and then I0. So whereas before we had to calculate I1, this time we have to calculate I0. So I0 is equal to the integral from 0 to pi by 2, this time of sine to the power 0 of x, which of course is just 1 dx. And therefore that integrates to x evaluated between 0 and pi by 2, and that is equal to pi by 2. So the integral that we've been asked to find then, which is the integral from 0 to pi by 2 of sine to the power 6 x dx, is therefore equal to 5 over 6 multiplied by 3 over 4 multiplied by 1 over 2, and then multiplied by our answer for I0, which is pi over 2. And if you evaluate that, you'll see that we get the answer, which is 5 pi over 32. Well, that concludes this video and indeed concludes the series of videos on reduction formulae.